Hello friends, welcome back to my YouTube channel. Today we are solving end semester question paper of 2023 Numerical Analysis and Design of International Institute of Professional Studies DAVV Indore. So now let's start with our first question. Find the roots of the polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for the various possible equations and show their nature, whether they are convergent or divergent in nature. So let's start with an assumption that fx equals to x square minus x minus 1, and we can see that f1 will be negative and f2 will be positive. Hence we can say that our root will be lie between x equals to 1 and x equals to 2. So we can take x naught equals to 1.5 as median value. Now let's proceed further. Let the function fx equals to x square minus x minus 1. Here are the following equations gx that can be made or derived from fx. We have four equations that we can derive from fx, that are under root x plus 1, 1 upon x minus 1, 1 upon x plus 1, x square minus 1. Now we will find their derivatives and we will make a table also. Here we have put gx, and in this column we will put g dash x. G dash x of root x plus 1 will be 1 upon 2 root x plus 1. G dash x of 1 upon x minus 1 will be minus 1 upon x minus 1 square. 1 upon x plus 1 g dash will be minus 1 upon x square, and x square minus 1 g dash will be 2x. Now we would find that the mod value of g dash at these values. Now we would find that what is the value of g dash x at our points g dash x 1 and g dash 2, and we would then derive our best equation which is beneficial for our calculation. So for the selection of correct gx we would follow two rules. First, g dash x should be less than 1, and if multiple values of g dash x are less than 1, then we will choose at least one of them. Okay, so now we check the values of g dash 1 or g dash 2 of these all the gx, and we found that only this under root x plus 1 gx has g dash 1 and g dash 2 less than 1, and either all of them have g dash x greater than 1 or equals to 1. So hence we can say that g dash x equals to under root x plus 1 is the best fit gx that we need. So because as it is convergent, so we would further our calculation with this gx. So now what we do in this fixed point iteration method is that first we take one x naught and then we put that value in our gx, then we derive our x1, then what that we get x1 we put it again in gx, and continuously we do this method until we get 2-3 digits constant after decimal, or we can say that until our error becomes less than 0.001. So we perform that calculation. First we found x1, then x2, then again put x2 in our gx and found x3, then we put x3 and find x4, and again similarly we found x8, and at last we see that the error between x7 and x8 has become less than 0.001. Hence we can say that our root will be exit. So this is the simple fixed point iteration method. Now we would move forward to our next question. Second question is, find the solution of the system of equation using iterative method. We have to find the solution of these three equations using iterative method. So for this we will first find the value of ABC in the respective equation by taking variable from one side. Okay, then what we will do, we will simply take A naught, B naught and C naught equals to 0 and start putting them in the in our equations that we found earlier. Okay, then in this way we will derive our A1, B1 and C1, and then again we would put the values of A1, B1, C1 in our earlier equations and found A2, B2 and C2. In this way we will do it in iterative way until we get some repetitive values, or we get some values where our after decimal some values become constant, as we have did here. We found A3, B3, C3 and we again put it into our equations and found A4, B4, C4, and we will repeat these steps until we get repeated approximate values. And here, as we get some repetitive approximate values, we have stopped and answered that these are our values of A0, B0 and of our A, B and C. So in this way we can solve it very easily. Now let's move forward to our next question, that is, list out 4 disadvantages of Gauss elimination and 3 advantages of iterative methods over the elimination method. First we will talk about the advantages of iterative method in superior to the elimination method due to following reasons. First is computational efforts is approximately 2n to the power 2 arithmetic operations per iteration, and if convergence is achieved in less than n iterations, it is significantly superior compared to the elimination method. Okay, I think you would understanding what is here want to say that. Next, move forward to next point, that another important advantage of the iterative method is small rounding error, the rounding error being the one committed in the last iteration. Thus for ill-conditioned system, an iterative method is a good choice. And the last main advantage is that in Gauss-Seidel method we set 9 equal to the newly calculated xi equal to the newly calculated value of the iterative stored in temp. So these are the advantages of iterative methods. Now we will talk about the disadvantages of Gauss elimination methods. First, the computational effort is approximately 2n to the power 3 by 3 arithmetic operation in each elimination step. The second is the amount of bookkeeping necessary is considerable. Third, the rounding error may become quite large, particularly for ill-conditioned equations. And lastly, any special structure in the matrix of coefficient is difficult to preserve during elimination. These are the disadvantages of Gauss elimination. Now let's move forward to our next question. In this question we have to write the algorithm for Lagrange inverse interpolation. So it is quite simple. First we have to read the number of inputs n, then we will read the value of x, and then we will run a for loop from I equals to 0 to I equals to n minus 1, and we will read the value of x and y. Then we will set our some variable equals to 0. Then again we will run a for loop from I equals to 0 to I equals to n minus 1, and we will set product equals to our another variable product equals to 1, and again we will start another loop for j equals to 0 to j equals to n minus 1, and if I equals to j, we will product our product variable with y minus yi upon yi minus yj and store this value again in our product. In this way, and at outside this for loop we will increment our sum by our xi into product. In this way we would found our answer and in our sum variable, and at last we will print our sum variable. So now let's move forward to our next problem, that is we have to evaluate the 1 upon 1 plus x square from 0 to 1 through the 3-point Gauss quadrature formula for the given abscissa and weight. So here we have to given the values of t1, t2, t3, w1, w2 and w3. All the values are given here. So firstly let we assume that our a equals to 0 and b equals to 1, and we know that the value of x is b minus a upon 2t plus b plus a upon 2. So putting our values that we have assumed, we get x equals to 1 plus t upon 2. Oh sorry, we have not assumed, it is given that a equals to 0 and b equals to 1. So here we get our value of x, that 1 plus t upon 2, and what we get dx upon d2, dx equals to dt upon 2. Now let's substitute value of x and dx in the fx. So our ft will be from minus 1 to 1 2 upon y plus 1 plus t square dt. Now let's integrate it and put the values. So what we have done here, that we have simply substituted it with our formula, and we have that is given earlier, and found the value of our ft. In this way we have find our answer through 3 Gauss point L quadrature formula. Now let's move forward to our next question, that is write an algorithm for the Vidal's rule for the 6 points. So it is quite simple. First we have to read our starting point and read our ending point, then we would find our h, that is n minus star upon 6, because we have to find for the 6 points, that's why we are dividing by 6. Then we will run a for loop from I equals to 0 to I equals to 6, and now we will read our the values of yi. Then we will at last we will assign our sum equals to 0.3 h into y0 plus 5 y2 plus 6 y3 plus y4 plus 5 y5 plus y6, and at last we would print the value of our s, because our answer will be stored in the variable s. This is the quite simple. Now let's move forward to our next question, that is write algorithm for Runge-Kutta fourth order method. So it is quite simple. As we know, first we will define our function, then we will read our starting, ending and splits point, then we will calculate the value of h by ending plus starting upon splits, ending minus starting upon splits. Then we will run a while loop until our starting is less than our ending, and we would find our k1, k2, k3 and k4 by these formulas, and at last we will increment our x by h and starting by starting plus h, and we will calculate our y or k by k1 plus 2k2 plus 2k3 plus k4 by 6, and then we will calculate, at last we will calculate our function values and print it simply. This was also quite simple algorithm. Now let's move forward to our next question, that is apply predictor corrector method to solve dy by dx equals to minus xy. Y0 is given to 1 in steps of 0.1 up to y 0.2. So we have to simply find the value of y 0.2 in steps of 0.1, and here we have to given y0 equals to 1. So first we would let's recall our formulas. What is our predictor formula is yp n plus 2 equals to yn plus 2hf x n plus 1 and n plus y n plus 1. Here is the point to be noticed that we are calculating n plus 2 and taking the value of n plus 1 and n. So this is the predictor formula, and corrector formula is n plus 1 and we will take the values of fxy and yn plus fx n plus 1 and yn plus 1. Okay, so now let's try to solve this question. What we see that here, that in predictor formula we can't find the value of y0 and y1. So we found the value of y0, y1 and y2 from this Hund's method. So for Hund's method we have to calculate x1 and x2 by this formula, and then we would calculate the value of k, and we would put this value of k in our main equation, and we would find the value of our yi plus 1. So in this way, when we do this whole method, we would find the value of y01, that is 0.1, that is our y1, because our y0 was 1 and y0.1 is our y1, and we have to find the value of y2. So next we will find the value of y0.2. we had to find this is our predicted value. Now we want to correct it with the corrector formula. So here we have, oh sorry, so here we have found the value of our predicted value, and here now we are correcting it. So what we are doing here is we are correcting it with our previous values, and we had corrected it till here, and we can also apply corrector formula again for more accurate value by putting this corrected value as predicted value in the corrector formula. Okay, so this is our end SAM paper, and this is our last question, and in this way we have to completely solve our end SAM paper. Thank you.